Okay, so in the previous tutorial, I think we have completed the building manager component. So now let's take a look at how we can place buildings in the map and let's say move our characters spawned from that resource building towards to the resources. Um, So actually directly jumping to AI movements, actually first we have to determine what are the available resources or nearby resources for a specific building. Then we can uh, determine what is the closest resource for a specific character, and we can move that character towards to that specific resource. Okay, um, so that's the idea. Uh, so First, actually, let's place some resource building. Maybe I will use a lumber hut first, right? So this is the lumber hut, and currently, if you simulate the game, or even if you try to play the game, uh, nothing will happen, right? Everything is static. No character spawns are there. Nothing will happen. So first, let's create a function to populate the nearby resources for this specific building, right? So basically it will search for nearby resources and record those resources or resource objects in a list. That's the idea. So first I'll open up the resource base. Okay, and let me quickly check my documentation as well. Okay, so first let's create a range, right, for this specific building, search range actually. So I will name this as resource search range, and it should be a float value. If you want, you can make it as integer as well, right? That's no big deal. And by default I'll make it maybe, I don't know, maybe let's say 500 instant readable, and I'll assign a new group called setup resource building. So actually we need to visualize this thing in the our resource building, right? So let's first add a box. No, not the box collision. It should be a sphere collision, right? Um, but actually I don't think we need any sort of collision responses, right? So I will make it no collision, and no need to generate all appearance as well. It's just a placeholder sphere. We need to it will be easy for us to determine what is the acceptable range, right, in the development purposes. So I'll go to the construction script and create that sphere and set sphere radius. We don't need to update any overlaps, and we can assign that range, right? So you can see now that range is visualized. So if you go to the map, here you can see that range is there, right? So what I want to do is that maybe I can increase the range, like let's say 800. So basically what I wanted to do, I need to capture all the resources within this specific sphere bound, right? So for example, these 3 trees should be captured by this specific resource building, right? That's the idea. So what I can do is maybe I can create a function first called populate nearby resources, and at the beginning play I can call this function and inside this function actually I had to trace for the existing resources. So maybe I'll create another function called trace for resources, and this should be a pure function because we are not going to manipulate it, we are just getting an output. So let's do multi sphere trace for objects, right? And yeah, maybe we can start from the actor location, right? And there should be a small variant for this actor location with the end location, otherwise the calculations may go wrong. And the search range is this range, and the object types. Okay, so in the object types, actually I think we can now create a new object type instance at our collision presets in the engine level, right? So let's do that. Then actually it will give much better collision detections, right? It won't, otherwise there is no point of doing collision detections for all the world static objects, right? We don't need to do that. All you need to do a collision test for the specific resources, right? So in that way actually we can have a better performance in our game. So let's go to the collisions, and I will add a new object channel called resources, or maybe let's say resource, right? By default everything will be ignored, and yep, yeah. Then we can make an array, and not the world static but resource. Okay, then we can maybe toggle trace complex, ignore self. Okay, and there will be a hit result, array of hit results. So let's go through that for loop, and let's break one of the elements, and if this is a blocking hit, which means we have found a valid resource, so I'll promote this hit actor as local variable called resource, and so this is just an actor type, but we need a reference for the resources, resource base. So therefore I will cast it to resource, natural resource base. Then we can get natural resource base object reference, and actually we need to check the types of the resource as well, right? Because let's say this is a lumber hut, right? So lumber hut is only responsible for capturing the these three object instances, right? So let's say there is a stone, so there is no point of recording that instance in this specific resource building. So actually we need to tag these object instances by specifying their respective type. So actually maybe we can create an enumeration for do that. So I'll create an enumeration called e underscore resource type, and I'll open that up. So I think I have three resource types. First I have wood, and I have stone, and I have what it called I don't know, maybe food, right? Because we have fruit plants. So now first let's go to our resources, natural resource base, and let's add the type. Let's say, I don't know, let's say resource type, and it should be that enumeration. Okay, and it should be instant editable, and let's assign it to setup as well. I'll make it bit upward. See, now I can select what is the existing or this the respective resource type. So actually this is the parent class. The parent class is not the thing we need to manipulate. We have to go through each of these base classes and we have to reassign the corresponding resource type. So this is a food plant based. So I can assign it as maybe food, right? Because food plant is a food resource type. Then I can go to the stone base and it should be assigned as stone. Compile and save. And I think by default tree base will be having this wood type because our parent class is having that specific type. So there is no need of changing that. Okay. So now we have correctly assigned the respective resource type. Plus we have to specify the resource building. What is the associated resource type? So I'll name it as associated resource type. And let's assign that resource type enumeration, make it instant editable, and let's assign it to the setup resource build. So I'll make it as the first variable that we need to change. Okay, now our resource building, we can specify what is the respective or associated resource type, right? So if we go to the our resource building types, we have 3 types of buildings, and the BP barn is responsible for handling food related resource types, and BP lumber hut is responsible for handling resource of wood type, and BP mine is responsible for handling stone type, right? So make sure to specify the associated resource type for each object instances of your resource buildings, and I'll save it all and close everything, and let's go to the BP building resource building base again. And here now we can check whether this specific resource type is exact same as our associated resource type. If it is, then that's a valid resource type that we need to capture, right? So I'll actually we have to iterate through each and every individual element, so therefore there will be resource list and it will be in this BP natural resources object type, and it should be an array. So let's populate that local array like this. We should add this resource, and what is that okay, maybe what's the reason? Okay, the reason is actually this resource list should be an actor type, right? So I'll remove everything because our resource in actor type, and it should be an actor type as well. Actor. Okay, now let's try to add it. Okay, so likewise we have to add each and every individual captured resource element, and at the end, once we complete the for each loop, we can return that resource list like that. Okay, so let's name it as return value. Okay, so now let's go to the populate nearby resource function, and what is this variable? Okay, this is not required. So let's trace for the resources, and let's go each and every element of it, and you have to check whether is it a valid object reference. If it is a valid object reference, we can actually cast for the natural resource base, and we can populate a nearby resource list, right? So I'll create a new this variable called nearby resources list, and that should be an natural resource type, right? Natural resource base. So now actually I can add unique element to it, right? Add unique that is casted out of this specific cast type cast. Okay, I think that's it. So for the just for the testing purposes, let's try to maybe at least print these elements in the array, right? Yeah, just for the testing purposes. Maybe I can do it over here like that, right? So get the display name out of it, and make sure to call that function in the begin play as well. Okay, so let's try to maybe simulate. Okay. Okay, why it is not captured? That's because of because we have we are doing this object collision for a resource specific resource type, but currently we haven't assigned that resource object type for our resource. So let's go to the natural resource base, and this specific static mesh can use for that collision detection, and let's maybe make it custom, and object type should be resource. Also yeah, for now we can block everything. Oh no, actually we can ignore everything, and we can block maybe pawns and maybe world dynamics, maybe world static as well. We won't be having any vehicles, and we won't be having any destructibles, and obviously we need to block the resource object type, right? Otherwise that collision won't be invoked. Now let's try to play it. Okay, now you can see it print out that values, right? So actually you can do for duration trace channel as well, so you will see how that collision works. See, the points that it has red mark is the possible collision detection, right? But let's try to disable this trace complex. Okay, still it detects, right? Okay, that's fine, because this trace complex is sort of expensive as well, because it perform a trace for that specific collision bound, right? But we don't need to do that. We can just rely on the approximations. So we don't need to actually enable trace complex, but if you want, you can do that. But for the performance reasons and optimizations, I think it's better to disable this thing out, right? Okay, so maybe let's try to place, let's say, what are the resource buildings we have? Okay, we have a barn as well. Let's try to place our barn here. So it should print these fruit plants display names as well. Okay, it print out, which means it detect those fruit plants. Likewise, let's place a mine over here and let's try to simulate again. Okay, stones also detected. Okay, great. So for now I will disable this draw debug type. Actually later on we can create some utility functions to handle these sort of development time changes as well. I will create those stuff later. And let's try to simulate again. Okay, everything works as it intended. It detects the trees and detects the fruit plants and it detects the stones as well. Great. So now actually the resource building is aware of what are the resources nearby to that specific building, and maybe in the next tutorial let's try to spawn a character nearby this building, and maybe let's try to move that character towards this specific reason. Okay, so I think that's all for this tutorial, and I'll see you in the next one. Thank you.